problem, the question asks, how do we find the normal plane and osculating plane of any vector at point 110 using this equation? Well, first what we want to do is find the derivative of RT, which will be the RT prime is equal to negative sine t, cosine t, and negative tangent t. The reason why it's negative tangent t is because the derivative of ln is 1 over x, and the derivative of cosine t will be negative sine. And here we use a power rule to get negative tangent t. Afterwards, you want to find the tangent vector, which will be the derivative of RT over absolute value of RT. And once we have that, it will be basically negative sine t, cosine t, negative tangent t over square root of your entire r prime t squared and add it up together. So it would be negative sine t squared plus cosine t squared plus negative tangent t squared. And once we have that, we will be left with tangent t is equal to negative sine t cosine t negative tangent t over secant t. Once we have that, we then want our derivative of t squared. But first, before we do that, we want to make sure that it's divided properly. So once we take it a step further, we'll be left with tangent t is equal to negative sine t cosine t cosine squared t negative sine t. And how I got that answer is basically t tangent t is equal to negative sine t times cosine t. The reason why that is because 1 over secant t is equal to cosine t. So basically, here instead of dividing by secant t, we times it by cosine t. And of course, whenever you multiply that, you'll get cosine t squared. And whenever you have a negative tangent, when you times that by cosine, whenever you convert that, it will be sine theta, or in this case sine t, cosine t times that by cosine t over 1. And what that does is, since it's a negative, this will be negative as well. These two cancel out, and you're left with negative sine t. Once we have that, we want to find the derivative of t tangent t. As long as we do that, we'll be left with negative 1 over 1/2 cosine 2t negative sine 2t, and then negative cosine t. Once we have that, we want to find the normal vector, which is normal vector t, much like with our RT, is equal to t prime over as the value of t, which, as mentioned before, it's negative 1/2 cosine 2t negative sine 2t negative cosine t over square root of our coordinates, negative cosine 2t squared plus negative sine 2t squared plus negative cosine t squared. once we have that, we will get our answer should be is equal to negative. Let me just erase this so I can write it much better. It will be equal to negative 1/2 cosine t, negative cosine 2t, sorry, minus sine 2t minus cosine t over 1/4 cosine squared 2t plus sine squared 2t plus cosine squared 2t. And assuming we're given, well, actually yes, if we assume that tangent is 0, we should get the units 0, 1, 0 when we plug in into our equation here. So negative sine 0 times cosine 0, that will equal 0 as a result of this function equals 0. Then when you times that by cosine squared 0, for the cosine you should get 1. Much like out here for the cosine, you should equally get 1, but because sine 0 is 0, that automatically will cancel out this 1. Likewise, for the negative sine t 0, you'll equally as well get 0. And once we should get these points. And so then afterwards, our normal vector at 0 should be negative 1/2, 0, negative 1 over square root of 1 over 4 plus 1. And the points that we get should equal 1 over square root of 5 times up by negative 1, 0, negative 2. Which, when to simplify, you won't be able to see it over there, which should equal negative 1 over square root of 5, 0, negative 2 over square root of 5. So then the equation of the normal plane should equal to, using the coordinates that we solved for at tangent 0, should equal x minus 1, y minus 0, after we multiply, equals 0. We should get that y equals 0. Afterwards, the equation, I'm going to have to be running out of room here in a short while, equation of osculating plane we should in essence get n. Let's see if no, I don't. So then I will continue on a separate sheet of paper. And take my off. I use this. So we should get that, like I mentioned before, the osculating plane is n equals n cross product t, which whenever you cross multiply should give us negative 1 square root of 5, 0, negative 2 over square root of 5, I swear. silence. 0, 1, 0 for the tangent, you'll get that n equals 2 over square root of 5. Actually, let me just skip here this on this line. Equals 2 square root of 5, 0, negative 1 over square root of 5. So then the osculating plane